Here is an example about we want to see the effect of the blocking. So an experiment is carried out to determine the performance of two different synthetic materials, A and B, for producing like shoe soles that we would have under on the bottom of the shoes. Material B is considerably cheaper than A, and hence, if equally durable, so we want to measure to see that which one is more durable, if they have the same level. Would be if they have the same level of that to being durable, so we would consider B because B is cheaper. At the 95% confidence level, determine whether or not there is any difference in variance between A and B. So we did the test. Let's say we have material A and material B, and here is the result for material A and material B. So for what we would do is that we want to compare these two materials, right? So you can pause the video and think about it a little now, and then come back and watch the rest of it. Think about what method we would use. So when we compare it like this, we have comparison between two sets of the data, materials for data for two materials, A and B. Generally speaking, we would use the t-test, right? So we would say, okay, 95% confidence interval, let's consider the t of the observed, and then go and find out the t from the table, compare them, and then you will say that, okay, if you want to reject the null hypothesis or fail to reject the null hypothesis, like the conclusion. So as a first step in this experiment, we're going to calculate the mean and the variance of A and B. So we can see that the mean is for the sample is 10.63, 11.04, and then for the variance we have 6.009 and 6.34, very similar. Let's consider the variance. Let's assume because we want to reach the part that we would see the effect of the blocking, but let's assume that the variances they have they would be the same for the population, and then because of that we can get the pooled estimate for the variances for t-test. So we're going to get the pool estimate SP power 2. So then we're going to calculate the amount for it. We have this equation for it is like that. You have the degree of freedom of the A, degree of freedom of the B. You're going to multiply it by each individual variance and then add them, and then you would divide it by the NA plus NB minus 2, which is 18 here. So we will find out the pooled variance. Think about it, that what is this 18? What do we call it? And then pause the video, think about it for 10 seconds, try to answer it, then come back and test to see that your answer was right or not. So this 18 here is degree of freedom. Whenever we want to go and learn for this one, when we want to go and read the T critical from the table, what do we need to do is that we need to have a degree of freedom, right? So here we consider 18 as that degree of freedom. So T observed, because we have the mean here and pooled variance, we can find out the T observed. The null hypothesis is that we would say that in their population, the means are the same for A and B. And the alternative hypothesis is two-sided here. It's not the same. So we would say that the T observed, it's going to be like the equation that we had. We want to compare the material A and material B, right? So it would be it's the difference between them. We would say, okay, so let's say Y bar A minus Y bar B, whatever we have for the sample, and for the population, mu A and mu B, we are hoping to reach that they're equal to 0, right? Their difference. And then we have the pooled variance here, we want to find out we can use it, the amount of the pooled variance, to find out the total, which is the standard error, the square root of the SP2 times 1 over NA plus 1 over NB. It's your standard error here. We're going to find out the amount of the T observed minus 0.37. T from the table, you can see 18, and we considered so far two-sided. And then we would say that we find out the value for the T critical as 2.101. And let's compare it with the T observed. When we compare it, we will see that, okay, so T observed is less than T critical. It's like that when we had the when we had the figure, we would see, let me just show you. So it's like this. Here, you can see. So what we have found is that it's two-sided. So here is T critical, right? The value that we found from the T critical comes from the table. So T observed here is less than T critical. So it's going to be here. Like, let's say T observed is here. So when T observed is less than T critical, it means that we are in this area, and this area is H null area. So we fail to reject the null hypothesis. Let me go back to the sharing mode. It's here, right? Okay. So the T observed is less than T critical, as I showed you on the board. What can we say is that we can say we fail to reject the null hypothesis. You can see null hypothesis was here, right? We fail to reject the null hypothesis. There is no difference between the two material, and we should use B. So far our conclusion is that we should use B, because B was cheaper, right? So now there is a problem. In reality, each person was given a special pair of shoes. One shoe sold with A and the other one with B. Like one shoe, like a pair of shoes that they gave it to me, let's say, as a person who was involved, let's say, in the test. Like one of the shoes like that I had, it was, the bottom was with the material A, the other one was the material B. The decision about whether to use A for the left or right shoe was made by flipping a coin. So person one, for example, these are the results for each of them, right? So person one, material A, 13.2, for example, the result that I got. A material B, 14. So each of the shoes different. We want to see which one is more durable. So we read the test. And then we have the difference for each of these, like for each person, you would have the difference between the A and B. So with this design, with the pairing, it is possible to compare the materials by doing the hypothesis test on the difference between B and A for each person. So it's like that for person one, person two, person three. So before we didn't consider like what's happening for each person, right? So we consider it generally. But here is like that, we try to categorize that for each person. And then we would say that the null hypothesis, the alternative hypothesis, so for the null hypothesis, the mu of the difference is equal to 0 for each of these, each person. And then for alternative hypothesis, we would say the mu of the difference, which is B minus A for each of these people, it's going to be not equal to 0. And then we are going to find out the average of D, like we would go here and get the average of all of these numbers. And then a standard deviation, like the variance and a standard deviation. The number that we would have, there are 10 people. So number of data points that we have is 10. We calculate the T observed here. And then when we find out the T observed, because we have the variance here, we want to find out the standard error. So it's going to be a square root of the variance divided by the number of the observation that we have. And then for the T, we are going to, T critical, we would say that, okay, so we have 10 data points, right? So it's like that, here we are just working with this D. We don't compare A and B anymore. We are working, we got the one set of data of the D, like you would say, like this is D1, D2, D3, D4, and then it's like that we have 10 differences, right? And we can compare them, and then we would say the T observed, we have T observed and T critical. So T observed is 3.35, but T critical is 2.263. 2. So T observed is greater than T critical. So quickly, if I want to show you here, it's like that T observed is here. Like it's outside the range, like outside the range that of the null hypothesis. So we would reject the null hypothesis, which says that their difference is equal to 0. The effect of pairing is to eliminate the variability present among persons, right? And this is important here since no two persons wear shoes out at the same rate. So blocking here eliminates potential bias that we could have and makes tests more robust in detecting differences. So blocking, we can see the effect of the blocking here. So blocking is very important that it helps us to make a better decision.